Hey, it's James from Finney Electrical. In today's video, we're doing some commercial testing with a subscriber. Let's get into this. So here we go, we're back at the big church. We're just going to test this bad boy. So obviously we've moved a few fuse boards. We're going to basically take ownership for that and test everything off, make sure everything's fine. If anything does crop up, we're going to fix it basically. So then, let's get into this. There we go, so we've got Joe today. There we go. So he's just doing a bit of shadowing. So he's done loads of install. What you've done it for 3 years, you say?
Yeah.
So he's done it 3 years, and he just wants to, like a bit of experience in commercial testing. So he's come down today just to check out what we do. So hopefully learn something. The first things first, we test him. We've got his laptop up, and we're just basically first going to fill out all the client details, which we can't show you, and then what we'll do, fill out all the board schedules. So obviously, a bit incoming, we're going to write down board schedules, what each breaker's doing, same again for this one, and then we can crack on testing basically, so nice and easy. There we go, so it's set up, so I've just filled out the client's details above, so we're not going to click that. Obviously, property type's commercial, it's a commercial project, we've got new and addition on here. So stuff we've done, we'll change this box just to make it more specific, but for now, just to cover stuff. Circuits added and altered to DB1, which will be the old 3-phase. New DB installed for aircon, so that'll be DB2. So obviously all that's new, so I have to test everything. And DB3 located to the side of the wall, so that's this guy up here. So again, as we kind of fill this out, we'll basically just update it and kind of bulk that out a little bit. And then what else we got? Extent of the installation covered, so we've got 100% testing of all final circuits. And stuff like the outside lighting, we haven't even touched that, so we're going to test the switch side of the lighting, just stuff like that. And then it's just a little declaration to say I'm the one testing it, and that's about it. So we've got next we're doing the supply characteristics of the earthing arrangements. So if you have a look at this big fat chunky monkey cable coming in, comes up into this 3-phase block here, so you've got L1, L2 and L3, and then you've got a little MET there, your main earth terminal. So obviously the earth comes off the neutral there, if you see that, so it's a TNCS that combine then separates, and then from there it goes out to all your bondings and your earths to your DBs. So we just need to detail that down here. So it'll be a TNCS, if you look there. Also we've got number of phases, 3-phase, number of wires, 4. So we've got the live wires, so we've got 3 line and 1 neutral. So your neutral's a line, is a live wire, there we go, I can't speak today. And then we're just going to fill out like the nature of the supply, so obviously it'll be 400 volts, and then we're just going to get a little ZE at source, and then that'll be this little section complete. There we go, that's that filled in then. So obviously we filled out the cable sizes coming in, the bondings, it's an 80 amp fuse coming in. Also we got cable sizes, so 16 sorry, bondings 10mm, and your earthing conductor's 10mm, can't use it today. What else we got? And then it's got an isolator, so it's BS5419, which is the old style isolators. So that's that. If you want to know the other isolator, which is the newest style, that is the 60947-3, so that's like the big red switch you see on certain isolators. That's about it, so that's filled out, and then comments on an existing installation in terms of like safety and that. So obviously we'll fill that out if we come across anything. So I'm just on to schedules inspection. So what I do is just fill it out generic, just because I know the site, and then what we'll do is change this later if it doesn't apply. And if anything crops up, I'll just have to write it down. So on an EIR, you can't actually give it a C1, C2, C3. Everything has to pass. Everything has to basically be spot on. So I just write it down and then fix it if we come across anything basically. So after that, we'll go onto the board and test. So again, what I'm going to do now is just take a picture of this side, that side, same again for that board, same again for that board, and then we're going to sit down, have a nice little coffee break, and just look at my phone and then just type all the results nice and easy. Right, so we're just going to get the ZE test and the phase sequence test. We'll do the ZE first. So what is the ZE? So it's basically the earth fault looping pins test. It's the earth fault path between line and earth, so it's like L1 all the way back to the transformer and back, So it's testing that resistance. So here we go, so I'm going to test each phase. So L1 to earth, L2 to earth, L3 to earth, and then we're going to take the highest reading, and that'll test the PFC, and then we're going to disconnect the earth for that, and then basically we need to disconnect all parallel paths basically to get the ZE. So we can probably do it from this MET. So we'll have to kill the power to site, disconnect this earth obviously, because it'll kill earth to site, so you don't want anything energized when that's happening. So we'll disconnect this, clamp onto there, and then do the same again, L1, L2, L3, and then take the highest reading. So we'll do the PFC first, and then we'll have to go around and make sure we can actually turn the power to site. So here we go. So it's on high current, if you can see that. So high current, I'm going to bang that on earth and do L1. Don't you can see that. There we go, 0.24. L2. 0.23. And again, 1.22, so I think this was the highest. So let's have a look for the PFC for this. Oh, apparently it's 0.22. So what we'll write down for the PFC is just 1.1. So there we go. And then when it comes to doing the ZE, we'll have to disconnect that parallel paths and basically test to the main earth coming in. Right, we've got the power off now, so if you use a little phone torch, we've got the earth connected up there. And then what we're going to do is do the same again. So L1 to the earth coming in. So 0.21, or it's, I don't know why, it's lower. 0.20. 0.19, so 0.21 is what we're going to write down. So nice one. Next little test we'll do is phase rotation, or sequence test, whichever you want to call it. So we'll bang it on. So on here, it's got, it even shows you, so L1, L2 and L3. So what we'll do is bang these on. So L1, L2, L3 it should be. So if we bang these on L1, L2, L3, we should get 1, 2, 3. If we get like 1, 3, 2 or whatever, then we know that the rotation is wrong. So 1, 2 and 3. See there, 1, 2, 3. Take your hand with and come with me. There we go. That'll do. So that's phase rotation, that just shows that it's actually coming in correctly. So there we go, we're going to write down the schedule next. So all the breaker sizes, like here we've got a B6, it's a 60898 for the MCB. So what we'll do is just take some pictures. So this is the quickest way of doing it, or the easiest way. There we go, I'll get a few pictures like this. So that's for DB1. Again, from those pictures you can determine cable sizes as if you're looking at it. So I find it a bit easier than trying to carry your laptop with you, and that way you can kind of sit down with a brew and write everything out. The last one's here. Oh, that would have been a bad picture. Just gonna make sure your hand's really still, otherwise when you zoom in you don't get a good picture. Right then, let's sit down and we'll write all this out. We filled out, here we go. That took a long time, so right then, here we go, all that's filled out. So we've got DB3, which is the single phase one, so that's all written in. So all I need to do now is, it's not very well labelled up, so what I've done is just write, if it's a 6 amp or 10 amp, I'll just put lights. If it's a 16, 20, 32, I'll put sockets for now. And then we'll actually go identify the circuits, we'll change that if need be. So obviously this is office 1, 2, 3, kitchen, little multi-purpose area. So basically we'll have to rename it to whatever the building's now called to make it a bit easier for the client. So that's that one, DB3. Then we've got DB2, which is the aircon stuff. So above me, there's a flat roof with loads of aircon stuff on. So I have to test all that. There's like a, yeah, they're all over. And then DB1, which is the older one, that does like most of the building, like the lights upstairs, the socket circuits, and there's loads of stuff being ripped out of that one. But again, that needs all testing. So let's crack on. Hey, before that, I think we'll get a bit of munch. So we'll have to treat Joe to something. Do you like curry?
Love it.
Yeah, well, we'll try out the Sheffield Bargee Shop, or Onion Shack, I can't remember what it's called. We'll try that out in Sheffield and see what he thinks, eh? Here we go, the Bargee Shack. That's what it's called. Oh, well, that was lovely. We got to film the food because it was so nice. What do you think then, Joe?
Yeah, it sounds really nice.
There we go. That'll do you. That'll do you. We've got one for Scott as well.
Hello, it was lovely.
Look at him. Right, back into the job. Let's do this. Right, we're back on it. So what we're going to do now is try and test some circuits. What we're going to do, turn on all the lights in the full building. I know energy prices going up and all that. But yeah, we're gonna have to turn everything on, turn the circuit off and see what knocks it off. So on here, first thing we're testing is, hello Joe.
Hello.
We've got this little 16 amp. Now back in the day, lights used to be on a 16 amp with a 1.5 cable. It looks like 1.5 or 2.5, can't tell. So what we're gonna do is get all the lights on, flick it off and see if it does the lighting. If not, we'll go around to the powered items, which is like sockets, fuse spares, that kind of thing, and see what's turned off. Lovely. Right, then we finally found out what it was, flipping heck. Hot lights turned on, it didn't do lights. So, can you just ping that on and off? There's a random fuse spare, that does, there we go, hand wash water heater. So what we'll do is get that connected up, and we'll do a test called continuity first. So basically it's testing line and earth, make sure you get a decent, it's called R1, R2 reading, so R1's line, R2's earth, and what we want to do is make sure that plus the ZE lands within the tolerance for that breaker size. So here we go. There we go, first test, continuity. So what I'm going to do is cross over line and earth with these little handy little clamps. I'm going to go over here, and someone's having a poo. Nice. It's going to stink. Oh dear, we picked the right test first, didn't we? Right, we'll come back to that one. Right, so next thing we're going to do is, we're not going to do the fire alarm either, because that guy's working on it and we don't want to kill him. I don't know. Right, we've got an outside socket. Let's do this instead. So some random guy came and put an outside socket in for a pump outside. So let's test that. There we go. Connect up. There we go, take two. So we connect up line to earth. There we go. Outside we go. Just going to get his testers and test between line and earth. There we go, little outside socket. Need a bit of force. Oh, they broke me out. There we go, we got him off. Right then, so we'll unplug these. So these would go to like random pumps on the ground really. I love this. So you install this and have very hot cables within, not these popping out for cameras and bits like that. And then instead of going up here, drilling through into that void above bathroom, it's on this monstrosity. Look at this. Nice. Got this nice wire through here. Drill through. So that's to drill through anyway, and then got his thingy on there. There we go, so we've got this off now. So let's just get a little test. It's on continuity. And there we go, 0.15, so nice and low. So now move on onto the insulation resistance. Obviously disconnect all your loads. So back there what we'll do is test between line to neutral, line to earth and neutral to earth, and then that'll be the insulation resistance done. Test done, nice one. There we go, insulation resistance now, so bang it on there. So obviously we've got, let's have a look. We normally, it doesn't really matter does it, but I normally like to send the voltage down the line one and not the earth for some reason, but anyway. Right then, so we'll press test. So what we're going to do is bang it on 100 volts, make sure there's nothing else connected on that. I'm not going to blow out up. There we go, greater than 100 mega ohms, or million ohms, which is loads. And we'll bang it up to 500 now. See 500 volts? There we go, greater than 500. So I'm happy there's no load on that. So what I do, you test between all your cords. Again, just bring it back down to 100, not 1000. Like I accidentally did the other day. There we go, 500, all's good, and neutral to there. So what that's doing is making sure, it's basically sending the voltage down, and it's telling you the resistance between the conductors, and if you get a really high reading, it means that the insulation hasn't broke down, so you don't need to rewire it. But if it's like less than 2 or 1 meg or something like that, and you need to look into that circuit. But yeah, if there's nothing wrong with it and the actual cable's broke down that much that you just need to rewire, it's just going to short to itself, it's that low. Yeah, so Joe's telling me about contacting people. He's contacted a few people and they've been very nice, have they, you know what I mean?
They've been a little bit unpleasant, let's say. So one guy that I contacted, he replied with, "Are you an effing idiot? Why do you think that I would help you get something that you can blow yourself up with?"
Nice.
I only want to learn testing.
I know. Yeah, it's daft, isn't it? It's daft. So yeah, there's some people out there who don't want to help lads like Joe. I don't know. You've got to start somewhere, haven't you?
Oh,
you got to get the experience. Yeah, we talk about these online courses where you get no site experience. So, but it was like a 6-week course. Apparently you can become an electrician, but then you kind of jump on site and you got no site experience. So like for Hayden, it's took him at least 2 years to get somewhat decent. And you've done a similar thing, haven't you?
3 years, yeah.
So have you kind of got your experience then?
I've been knocking on people's doors, begging and pleading, just like today, sending messages, asking if anyone can help. I'll labour for free, I'll work for free, and it's worked out so far. And now I'm an electrician.
Yeah, he's nearly qualified.
Got a long way to go.
Like it. Right then, let's do a neck test then. So it was Hayden in the toilet. I can't believe it. So yeah, we'll take that isolate off the wall and get a test there. Yeah, I don't know if you can see me, but we've tested this. So we've got 0.14, but then there's another cable coming out and it goes up to here. Look at this above this roof space. Little flex here hanging out live. So we just took the fuse out. So this is why you test, so you don't end up with some live cables hanging out, electrocuting people. I don't know. There we go, a little test, 0.28. That'll do. So that's your continuity test. That's just testing the resistance between line and earth from the fuse board to here. Cause if you remember that link we did before, we caught someone at the toilet. So next, disconnect our loads so we can just test the live side of the switch, if you want to call it. We'll turn that switch off, that'll disconnect the loads, and then we'll give it another test for insulation resistance. So again, test between line to earth, neutral to earth, and earth to neutral. I think I got that right. There we go, that's the insulation resistance test done, all that screwed back. So we've disconnected the little flex out of there just so people can't turn it on and get a shock, so that's good. So now you've seen how we do a radial test, which is that goes from the fuse board to every point and stops. We're now going to do a ring test. So that's obviously from the fuse board. We've got sockets as a ring, so we're going to test the sockets for the left hand side of the hall. So it goes from the fuse board to all your sockets and back. That's why it's called a ring. So with that, there's a few tests. So you've got your end-to-end continuity tests. You've got a crossover test, which will test the R1, R2 to get the resistance for that circuit. And then again, insulation resistance. So let's crack it on. Here we go, right, socket circuit. So this does the up hall left hand side. So what we'll do is get this turned off. Oh, it's turned off, Hayden. A lucky kid. Change of plan again. Right, we'll do the sockets for the right hand side. So we haven't actually wired this in yet, so they're kind of sticking out the front. So we'll find that. Let's have a look. Sockets, not that one, it's this one. So sockets left hand side of hall, upper hall. Oh, battery's right hand side, we've wired it left hand side. So we'll get this stripped and we'll do some dead testing on this. And then obviously when it's all up and running, and we can get this powered up. There we go. There we go, so we'll just strip this cable then. So that does the upper hall right hand side. So it's like the kitchen and the right side of the hall. So what we're doing is it's called the end-to-end test. So we've just gone line to line. So obviously it's wired from here to every socket and back. So that's where you get a ring. So what we got, 0.53. And what we're going to do is connect up neutral to neutral. And we should get a similar resistance because it's the same size cable. So 2.5 obviously. 0.53. Hey, that's good. That means we've got some good terminations. If you had a big difference, then obviously you've probably got like a loose connection. But if it's within like 0.01, 0.02, it's going to be pretty decent. If you got like 0.05 difference or something, you're like, right, there's some dodgy connection going on, you might need to investigate. So it could get worse. So we've got earths, 0.90, 0.89. Right, we'll go with that. So we'll write those readings in here, fill it out. So there's a section for that. There we go, that's that filled in, so 0.53 for both and 0.89. Here we go. So what we're going to do is do a crossover test to get the R1, R2. So we're going to take the line coming in and connect that to the earth going out and the earth coming into the line out. So we'll cross them over, and then what we'll do is just plug in this tester and test between line and earth all the way around, and we should get a similar reading within like 0.05. Right, we'll go around and test between line and earth. 0.42. 0.39. We'll go around all of them and then get the highest reading. Can you hear me? Hey, check this out. This is why you test both sides when you're testing. So 0.40, that's an alright reading. This side. And at 1, Flipping heck. So before it was 1.1, so 1.1 is straight away I'd fail because the B32 is 1.1 is your maximum. That's when you add on your ZE as well, so not good. So this is where you test both sides. So it's a brand new socket and you get faults with them, so that's why it's important to test and don't assume that because you installed it's going to be right, because that brand's let us down really. I don't know. Last little test, insulation resistance. So bang it on, I'll bang it on 500 because I know it's brand new installed, it'll be all plugged in. So again, earth to line, earth to neutral, line to neutral. Because it's a ring, you just test one side, it's obviously going to pick it up that side. There we go, beautiful, that's all passed. Well, that's it for testing. We've got a bit more to do down here, so we'll crack on. But yeah, you learn how to do the radial test, so it's the continuity and the insulation resistance, and then the ring test where we've tested end to end, and then got the R1 R2, which is the continuity test, and then the insulation resistance. Make sure that the cable's fine, it doesn't need rewiring. So yeah, that's us done down here. Have you found it today, Joe?
Yeah, it's been really good, really informative. Thank you very much for having me.
Yeah, no worries, no worries. So that's it from me and Joe. As always, have a good one from me, and I'll see you on the next one.